Hello, we are just going to review how to use point slope form when we are finding our equation in slope-intercept form. So the first three examples you see here on this slide are asking us to write the equation in slope-intercept form of the line that is parallel to the graph for each equation and that it passes through the given point that you're given. So if we look at the first example, number 1, we see that we're given an equation y equals 3x plus 6 and a point of 4, 7. So in class, we talked about this form y minus y1 equals the slope times the quantity of x minus x1. Remember, this is called point slope form. We use this equation or this form when we have a point given to us and if we know we have a slope. If I look at this problem here, I see that I have a point of x1, y1. I know my x1 is positive 4 and my y1 is positive 7. So I have the point. And now I need to identify my slope in order to use this equation. If I look at this, they give me an equation instead of just a slope. So if I look at this formula, I notice y is by itself, and it has an mx plus b. So they gave me an equation in slope-intercept form. The only thing I care about when I look at this example is what the slope of the original equation is. The slope of the original equation is m equals 3. Okay? So in order for me to figure out what my new slope is going to be, I need to remember what the definition of parallel means. The definition of parallel means I have two lines that never intersect. These two lines never intersect because they have the same rate of change or the same slope. So since the original slope is positive 3 and I want it to be a parallel line, then my new line is also going to have a slope of positive 3. Okay? Now that we figured out our slope is positive 3 and our x1 and y1 are the values of 4 and 7, I can use point slope form to figure out my new equation that will be parallel to the original. So I have y minus y1. I know y1 is 7. My slope is positive 3. And x minus my x1 is positive 4. All right. Once you replace the coordinate of x1 and y1 and your slope, it wants us to write our equation in slope-intercept form. And slope-intercept form is the most common that we use when we want to graph something. That is when y is by itself, which we just talked about a second ago when we identified the original slope. So I want to get this to look like y equals our slope x plus our y-intercept. So we want to get y by itself. So in order to get y by itself, I need to figure out how to get rid of those parentheses. And in order to get rid of parentheses, we know that we're always going to distribute. And the number that's in front of the parentheses is 3. So I'm going to distribute my slope to everything inside the parenthesis. So 3 times x is 3x. And 3 times minus 4, positive times a negative is a minus, is a negative. 3 times 4 is positive 12. So once again, when you distribute your slope, you have to multiply it to the x and the constant that is behind it. And finally, now that our parentheses are gone, the only thing that I need to get rid of now is whatever is attached with the y. I notice y has a -7 behind it. I need to do the inverse to get rid of it and put it to the other side of the equation. So I'm going to add 7 to both sides of the equation. When you add 7 to both sides of the equation, you're only going to combine it with our like term. And our like term is -12 and positive +7. So we have y equals 3x. I just carry that down. And -12 plus 7 is -5. And then that is our parallel line, our parallel equation in slope-intercept form. All right, so if we just review this, we need to identify our x1 and our y1, so whatever the point that they give us, and also our parallel slope. Once you have those parts, you're able to use or substitute into the point slope form and then solve for y. Okay, so if we look at, let's look at example 3 quickly. We know our x1 is +4. We know our y1 is -5. And our slope, remember, it's going to be a parallel slope. Parallel to, remember, it's y equals mx. So m for the original one, we see here is 1/2. We want it to be parallel, so we're not changing it at all. So it's just 1/2. And then you plug it into the equation. So it's y minus the y1 value is -5. You notice there's a double negative. Our slope is 1/2. And it's x minus my x1, which is +4. This double negative right here is going to change to a +5. And then remember, you always distribute your slope. 1/2 times x is just 1/2 times x. 1/2 times -4 is going to be -2. Remember that 1 times 4 is 4. Divide that by 2, and you get -2. And then we subtract whatever constant is behind the y. So I'm going to subtracting 5. So y equals 1/2 x. And then -2 and -5 is -7. Okay. What we're going to do now is go over the perpendicular, because I know that is the one that most students struggle with. So if we look at the second example, we're doing the same exact thing, except it wants us to write an equation in slope-intercept form, given that it is perpendicular to the graph of each equation and passes through each point. So once again, just like before, we need to figure out what our coordinate points are for x1 and y1 and our perpendicular slope. So we have to find our x1, our y1, and our perpendicular slope. So if I look at this, for the first one, our x1 and our y1, our x1 is just +2, our y1 is -1. Now, the original slope, our first original slope is -5. Remember, you're going to change the sign. So instead of it being a -5, it's going to be a +5. So it's opposite. And then we're going to do the reciprocal of the original slope. So I'm going to flip it. So it's going to be, instead of it being 5/1, like it is right here, it's going to change to 1/5, +1/5. So my new slope is +1/5. So you take the original slope, you change the sign, and then you flip it from 5/1, you flip it to 1/5. And then you do the same thing. Y minus y1 equals m times x minus x1. So our y1 is y minus -1. Once again, we have a double negative. So we're going to change that double negative to a y plus 1. And then our new perpendicular slope is +1/5, 1/5. And it's going to be x minus, inside the parentheses, x minus +2. And to get it into slope-intercept form, you distribute your slope. So 1/5 times x is just 1/5 x, minus 1 times 2 is 2 in the numerator, divided by 5 in the denominator. And then the last step is we subtract 1 to both sides. So we have y equals 1/5 x minus, now we have a fraction and an integer, so make it a common denominator. So it's a -1/2 minus 5/5, because 5 divided by 5 is just 1. Since they're both the same sign, you just add your numerators. So 2 and 5 is 7, and then the denominator stays the same of 5. And that is your slope-intercept form of the perpendicular equation of the original one. Okay. If we look at the next one, let's identify. We have x1 is -5 and y is 3. Our perpendicular slope, the original slope, is +2/1, or just 2. To find the perpendicular slope, we change the sign. It originally was positive, so I make it negative. So it becomes negative, and we do the reciprocal, or we flip the slope. So instead of it being 2/1, it's 1/2. So my perpendicular slope for the second one is -1/2. Okay, and then you would do the same thing as we did on the first one. You plug it in just like the same way. It's y minus y1, so y minus 3 equals, our perpendicular slope is -1/2 times the quantity of x minus -5, because that's my x1. So this right here is going to change to a plus. So we have y minus 3 equals, when I distribute, we have -1/2 x. A negative times a positive, since I changed that to a positive, it's a negative or minus sign. And 1 times 5 is 5 in the numerator, divided by 2 in the denominator. And then we add that constant of 3. So we get y equals -1/2 x. I just carry that down. And then -5/2 plus 3. We're going to change 3/1 to the denominator is going to become a 5. So I multiply 1 by 5, so it means I multiply the top by 5. So that 5 times 3 is 15. So instead of it being 3 over 1, it's 15 over 3. And 15 is bigger than negative 5, so it's 15 minus 5, which is 10. Oh, I made a mistake. I am sorry. It needs to be over 2. So I'm going to change 3 over 1 to over 2. Since to change 1 from 2, I multiplied it by 2. Multiply 3 by 2, I get positive 6. So now I can throw that one out. 6 and negative 5 is positive 1, and the denominator stays the same. So it's going to be negative 1/2 x plus 1/2 for my intercept. And that is my perpendicular equation. So overall, for perpendicular, when you find your perpendicular slope, just remember, you look at your equation, identify the original, that is negative 4. You are going to change the sign. So if it was negative, it becomes positive. If it was positive, then it becomes negative. And then always write your slope as a fraction if it's not already. So put it over 1 if you have to. And then you're going to do the reciprocal. So I'm going to flip 4 over 1 to be 1 over 4. And then you do everything else the same way.